Thank you, Andrea, for the great opening, and it's wonderful to see you all here today. I'm going to talk about the innovation ecosystem we've been developing at Stanford. This is meant to be a very open dialogue. Talk about how we can work together to innovate in a space where we realize we haven't gotten to the end yet, right? So we've got to keep pushing. I'll use Andrea's slides here. There's a lot of overlap. Keep going. All right. A lot of clicks. Okay, there we go. So something monumental happened at Stanford 3 years ago. We started our first new school in 3 years, the School of Sustainability. Prior to this, we had 6 schools at Stanford, but there was a realization that we needed to transform academia to have an impact in the things that value to society in the future. There's a lot of new thinking about how we formed this school, both internal to Stanford and how we got the donor and the gifts to form this school and what all of those experiences form. So the first thing that we did is it is a culture of entrepreneurialism. That's key to Stanford, who we are and what we do. And I'll talk about that more and how do we translate that into carbon removal, carbon sequestration. It has to be incredibly collaborative. This is extremely complex, as Andrea talked about. It's not just about science and technology. It's about communities. It's about people. It's about natural resources. And it's about policies to allow that to scale. And so we've purposely brought in faculty from all schools across campus, and we're working together to do that. But we also realize at the school itself, we are ourselves a startup. Nobody has figured this model out. So what is the proper way to educate? What is the proper way to do this science, to get it into the world? And that's what we're pushing on very hard at Stanford today. So what makes this school very unique amongst the others at Stanford is the Sustainability Accelerator. This is where I sit. All of the 6 other schools that I showed you have 2 core components. The academic departments, that's the core of what we do. We teach, we educate, we give degrees. We train that next generation to go out and make an impact in the world. Second, our interdisciplinary institutes. We're fortunate to have the Precourt Energy Institute, the Woods Institute of the Environment, an Oceans Institute, and now a new Sustainable Societies Initiative. But what we didn't have in any school is an accelerator that was linked fundamentally to the organization, to the dean, how that school works. And that's because we're only here for one thing, which is to make an impact on the world, on our climate challenges. So here we work amongst all of those faculty, all of those students in a way to get these ideas out into the world. And I want to zero in the world ideas. It's not just technology, as we heard. We need everything. We need communities, we need policies, and we need market enablers. These are often very hard things in our culture at Stanford to think about how to work on and externalize, but we have to figure out ways to do that, to get them to grow and bring change. And so that's our purpose here. We have to accelerate this translation of Stanford research into scalable solutions and address these urgent challenges. So we have an incredible history of entrepreneurialism. You know most of the names on this. This is trillions of dollars of market cap. But what's really interesting about this, none of these companies are the sustainable companies that we need to achieve our goals. We talk about gigaton scale removal. To be gigaton scale means you're a $1 trillion type company. We don't have anybody right now we're pointing with on the trajectory to get on this map. So we have to be very honest with ourselves and think about that. That's why we're here. That's why we created the Sustainability Accelerator, to recognize we're not doing it the way that we need to succeed. The way that we train the entrepreneurs, the way that we spun them out, that is not working in sustainability. So the school is called the Doerr School of Sustainability because we got the largest donor gift ever in the history of Stanford by John Doerr. His company is actually the smallest one on here, Kleiner Perkins. So John Doerr is one of the most famous venture capitalists in Silicon Valley. They invested in many of the companies on here. So he gave a $1.3 billion gift to Stanford. Why was he motivated to do that? Because Kleiner Perkins led what was Clean Tech 1.0 revolution in venture. And it almost killed Kleiner Perkins. They did not make any money from it. In fact, they lost billions of dollars from it. Why was that? Because we tried to push the same venture model onto sustainability and climate as we did to the internet, to semiconductor, and to that type of technology. These are very different markets. These are very different challenges, and we need new models. That was why that GIF was unlocked and this school was formed. And so every day within Stanford, we think about that. So what is the capital stack? What is the return profile? How do we have to build these organizations and ecosystems in order to get these companies to succeed? Within the Sustainability Accelerator, we organize around areas called flagship destinations. We have 8 of them. And John Doerr, I don't know if any of you have read or seen his book called Speed and Scale. John is very formulaic. It's very simple to him to solve climate. We just reduce our emissions. We remove CO2. That's what it is, gigaton scale. So, okay, let's go for it. Well, when we sat down to figure out how we actually do this, it got a lot more complicated than that. And what we found is this system works very well for issuing RFPs and granting money and organizing teams, but it's actually a lot deeper than this when you dive into it. So food and agriculture, reduce emissions from agriculture. Okay, great. But what about climate adaptation? How do you measure gigaton removal from climate adaptation? You don't. But if we do not think about climate adaptation, if we do not think about the billions of people in this world, we're not going to develop the proper solutions. Same thing with water. Water is not a direct initiative on carbon itself, but water is the key to life. And what we've learned is all of these things are interconnecting. So we fund and we grant on a basis of these 8 categories. Each category has a very large measurable goal that is on this gigaton scale. This is how we measure projects. This is how we grant them. We want to be thinking big. But in the reality underneath, this is a way for us to engage everybody on campus, because that's ultimately what this is about. Can we get everybody? Can we get the lawyers? Can we get the business people? Can we get the soil scientists? We actually need to gauge everybody. And what we found is this structure, this granting profile, allows everyone on campus a chance to contribute to these challenges. And that's what this is about. So we currently have 93 active projects. So this is when within 18 months on campus, we've granted 93. We're the single largest granting group on campus already. And again, what's special about this is out of those 93, I would only put 45 of them in the classical tech science bucket. The other 48 of them are policy projects and what we call market enabler projects. These are not teams and projects that are going to go out and raise a bunch of money, but they are the trust layer, they are the infrastructure layer that we as universities and scientists need to build to allow these markets to happen. It's equally as important that we fund that technology and we innovate ways to get that in market as we do maybe the next great removal technology that could become the billion-dollar company. We have 138 faculty engaged with these 93 active projects. We have the largest faculty engagement of cross departments and cross schools of any group on campus. We have over 203 students and postdocs. This is real serious horsepower here we're bringing to this problem. And the key here is we immediately push these teams to externalize on day one. We run these projects differently than you would think about a normal university grant. Our dean, Arun Majumdar, came from ARPA-E. We've adopted a lot of the concepts from ARPA-E into this. How do we manage projects? How do we scale them? We bring significant amount of these resources to the teams. We bring in assistance around techno-economic analysis, around business plans, around IP, around strategy, around accessing communities, accessing our politicians and developing policies around it. This is the name of the game, and you have to start on day one across your entire supply chain of whatever problem you're working on. And in our initial 18 months, we've already had 8 exits to date. We actually think we're going to have an incredibly high rate of exits from this program. Of those 8, I'm happy to say 2 of them were policy exits. So we actually got legislation approved in California in climate and sustainability challenges with this approach. 4 of them are venture-backed startups. 1 of them is a direct license into a large-scale company, and the other one is a market enabler. So we are very open. We are very willing to understand we need to innovate our model and embrace all solutions and work with these teams on how we best get to market. So let's talk about the greenhouse gas removal flagship itself. So we've organized here in a way, and we're strong believers in the cohort model. So how do we get all this great talent? How do we put them together? How do we allow them to work together to create the next great idea? One of the visions that we have is these first sets of grants and RFPs are not going to be the winning ideas. They're going to move the market forward and we're going to learn, but it's the learning, the cross-learning from all these teams working together to actually create that next idea is what we're really hungry to go out and find. And we're starting to see that. So we actually just issued our new RFP. We have our next set of proposals and LOIs coming in. You can already see how much the thinking has improved, how much the learning has improved from this. And so we need to keep this cycle going. We need to show the faculty and students that we're here to stay with this money, with the support, and we need to keep pushing and working together to go out and achieve that goal. So we purposely funded here very broadly, you can see on the bottom of the slide, across the full technology stack of removals. So whether that's nitrous oxide removal, methane removal, direct air capture, in the terrestrial space, we've got a couple of forestry projects, reforestation, agroforestry, biochar. We look at worms as a form of enhanced rock weathering and improving soil CO2 uptake. We have a negative carbon cement project that takes recycled cement and absorbs the CO2 from the air and its reprocessing, enhanced rock weathering. In the oceanic space, we fund the 3 core technologies there around biomass, direct ocean capture, and ocean alkalinity enhancement. And the most important thing, like I say, is all these teams work together. So we have cohort lunches every month, we bring in speakers constantly, and we're constantly interacting with this group. It's really important that the oceans teams see the problems in DAC, and they think about those problems. How am I going to solve them? It turns out enhanced rock weathering is very close to ocean alkalinity enhancement. How do we think about that field as a whole? How do we cross-fertilize between that? Above the technology layer, we've built this, what we call this market enabler layer. So MRV, sensors, measurement, economics, financing, and risk, and how do we build that scale? And again, these teams are partnered directly with the technical teams, so they're informed, and we're piloting and we're working together constantly. And then the last piece is policy and social impact. You can almost think about this as the exit velocity to get this going. You have to have a technology, you have to have a market, and then you have to have a policy for us to get this to work. And each one of these layers will inform the one above it, the best way to do it. So we work across all of this. You can see the policy and social impact has no projects in it yet. That's because we've been learning. We've been waiting to see what core competency do we have at Stanford within these projects? Where do we think we can put the markets with the technology and pair them to make a difference? And then we will go out and actively fund those. So we hope to have our first policy impact funded here in the next 2 to 3 months, and that will be around biochar and wildfire prevention. But this gives us a really unique view on the world. We have a core competence amongst all the technology. We have a core competence around all the economics of it and the scaling challenges. And this lets us now innovate much quicker around what we see is going to win and what we need to do to get there. So like I say, we've built this incredible cohort. I invite all of you to Stanford. We have an amazing new space at the Sustainability Accelerator. It's purposely designed to bring people together. And we bring people together constantly. And we mix that up. We want a mutual appreciation for your ideas. So there is no one silver bullet here. There is no one solution. When you think about the world, you think about natural resources, you think about climate impact, how it impacts everybody differently, their community struggles, and what they have to deliver. We're going to need almost every solution that you see on this page in one way or another. It's just where you put it and how you engage with those people that they achieve the value from that. We have to amplify our success, right? This is an incredibly difficult field to succeed in, and we have to share those success stories. And the one that I like the most about this group is we have to have a tolerance of novelty. We have to keep pushing very hard. We have to think about ideas out of the box. That's why we have a project like global warming. That's why we have a project looking at nanobubbles and how they can reduce methane. These are not things that are typically in the literature as ways to do carbon removal, but we need to bring them into the cohort and we need to explore and we can see what they can bring. So we view we've been very successful here so far at Stanford. We've changed the ecosystem model on campus. We've changed our funding model. We've changed how we interact, but we've run up against our own walls. This problem is so much bigger than any one university. So that's why we're here in Denmark this week. We're having an incredible week with our colleagues here and learning, because very quickly we have to now take this learning and we have to say, how do we do this now and partner across the global stage? So here we have to leverage for this problem every layer of this: universities, NGOs, corporates, and governments. To solve a problem like CO2 removal, we need that. This is not about starting an AI company, right? This is much more difficult in the integration and how we approach that. So we've built an incredible partnership with NOCC US. Actually, they were our first international partner. Thank you very much, Karina and Josephine. And this week really has exemplified why. This is another broad granting authority here in Denmark. I think they said yesterday there's something like 120 projects that they have funded here across the country. If you look in carbon removal, they have different terms and different words, but at the same time, it's the same core technologies we're working on at Stanford. They're not duplicative, they're complementary. And we actually have to think really hard about how do we get these resources to come together to push the field and get these solutions to market faster. And we've had a lot of great discussions this week, and I can only hope that we continue to push. And we have to realize the limitations of our model. I'm looking inside of Stanford. NOCC US is looking inside of Denmark. How do we make that broader? How do we actually create the funding mechanism? How do we create the space for our faculty and students to be able to engage across that the way they need? So this is where we, as the organizers and administrators, we have to push ourselves very hard and make sure and realize we're actually not giving our teams what they need to unlock this at the level that we're asking. And that's our challenge to come out of these types of engagements, to figure out how to do that. We've recognized this problem inside the US. We talk a lot as a community, and we've started to form what we've called a CDR community of practice, because we're all now running up against the same problem within our universities and granting. It's going great, but we're not doing this alone. This is a completely grassroots movement between people in CDR in the US. We've identified 6 core areas where we're organizing our subgroups to work across. Research is clearly number 1, better coordinating, but education is so important. I think Andrea talked about it really well. How are we talking about this to the world? The world does not care about CO2 removal. We have to just get that and realize that. So what is the right way to communicate that the world cares about this? We're trying to form a buying coalition in the US. One of the things that we struggle with is we're telling everyone to buy carbon removals, but we as universities are not buying them ourselves. Why is that? Why can't we get our own administrators to agree to use some of our school money to buy removals? If we can't convince them, how are we going to convince the world? But we also need to get our teams further into the market. By doing that, we can participate in these projects, we can get the data. Probably our most active area is in protocol development. There's a lot of protocols going on. How do we do removals? How do we measure them? How do we count for this? And we need to stay engaged. We need to communicate across that. And we need a better mechanism to opening that up and getting that feedback to get the most practical and pragmatic protocols in place possible. Policy, we are challenging the policy model right now about how we do that. Everybody, Ida mentioned COP really quick, but think about what happened at COP this year. Not a lot of it was positive. Is that the approach we're going to keep going down CDR in order to achieve impact, or do we have alternate policy models? And then ultimately, our scale challenge. So we're pushing very hard now to go outside of our boundaries. I think one thing that we lose track of in CDR is we're part of a much bigger story here around emissions reductions. And we have to realize what we're asking corporations and communities and governments to do. We're a small part of that, right? Like the 40 gigaton budget of emissions, we're going to achieve the majority of that through abatement and reduction. And then the part of that we can't, that's when removals come in. And so we're not in a vacuum. So these are 3 things that we're pushing on at Stanford, and I just want to bring to the discussion to think about a little bit different. differently. We have to have policy. There's no way around it. I think we all view the voluntary carbon market as been phenomenal as a way of piloting, as a way of learning around getting things to development. But if we do not have policy, we're going to get nowhere near our scale. But I think the challenge that we have in this very challenged political environment, it's not just in North America that we're challenged now globally. What are we asking our politicians to do? What are the challenges that our politicians face? And increasingly, the biggest thing is economics of the country, of the people, people's prosperity. How do we play a role in that in a positive way instead of viewing as we keep trying to take money out of the system that does not give back? We're putting our policymakers in a very, very difficult spot. When you do the math of it and we talk about the social cost of carbon, $100 to $50 to $200 a ton, and you do the math, 40 gigatons a year, that's $8 trillion a year, basically. That's what our core fundamental are asking for. That's just not going to be possible as a percent of GDP. So how are we going to bring these technologies to market to be able to enable that? It does seem possible 1% to 2% GDP, but have we delivered the technologies to abate, to reduce, to remove that can enable that? This is our challenge that we need to look at. And I had a really interesting call with a congressman in the US, and they basically said, we're here, we need your help. Give us something that we can leverage. Give us something that's bipartisan. And think about, and it takes a while to think about what they were asking. Don't tell us about removing CO2. Bring us something around changing the fertilizer market, increasing crop output for farmers, reducing wildfires. Those are the topics that people care about, that CO2 removal can be a key piece of mitigating. That's how we have to package. That's how we have to communicate. And they're asking for our help because they don't know what to do. Some of it, it's really scary thinking about what's coming because we have people out here who are doing a lot of great things in policy. It is coming, and are we going to be ready to deliver? So we need to have the infrastructure in place. A lot of the meetings with the teams all week have been talking about how we have that. We've got MRV. We've great pilots here going on. At Stanford, over half of the teams that I showed on that slide were piloting on Stanford land. We have to get out because it's coming quick. Here in Denmark, I think it was in 2027, need 2 million tons of biochar to start happening in market. How is that going to happen? Where's the feedstock? What's the processing? How are we going to measure it? Where are we going to deploy it? So that's going to come very quick. We got to be out there. It's got to be ready to go because in the end, it's about trust, right? We can't keep eroding trust. We're going to have to succeed when we get out there. And then we have this ultimate challenge around how do we address harms with no direct consumer demand? I think there's a tremendous amount of business model innovation in this field yet to come. How do we actually touch people? How do we package removals and emissions reductions in a way that we're actually a solution to adaptation and global problems that we have around food and the things we'll need in the future? So one of the things we talk about, what are alternate ways to think about our ecosystem? How have we tackled other giant problems to humanity? We can look at the Manhattan Project, the Human Genome Project, the Apollo moon landing. That's how we got the term moonshot, right? We're on a moonshot here, but we don't operate like they ran the Apollo program at all. Just most recently, we had Operation Warp Speed. How do we solve COVID and the vaccine problem? It's interesting, CDR to date, we've spent around $8 billion so far. Now, of course, behind these numbers, we spent a lot of money of these too, right? That was after we had fundamental science, and we've got to recognize this is money well spent in CDR so far. But are we organized in the right way for today's geopolitical climate, for what we can accomplish as universities, our model to achieve that goal? And so this is something I don't know the answer to. This is something I want to be very open about. How can we push this model about how we work? And what makes us very different about all of those, if we have no natural, organic, or self-propelling demand curve for CDR, this is the challenge. Every one of those, you could point to the why. How did we organize? How did people buy in? How are we going to unify ourselves in this field to get that level of interest, that dollar commitment over the time it takes in order for us to solve it? I think we're getting close to that. I think we have ideas, but ultimately, until we unlock that, we're not going to get to the solutions at the pace we need. And then finally, There's some learning if you look across those type of projects that we can adopt from their organizational strengths that we can think about. Parallel development strategy. I think we're much too worried about picking the winners. There is no one winner. We're going to need a lot of winners in this space, and we need to have a portfolio approach. It's not nature-based versus durable. It's everybody working together. They all add value to this problem. We need to prioritize deployment over science perfection. Our science is remarkable in a lot of areas, and we need to understand where our gaps are and what things are ready to deploy. Like the biochar discussions this week have been incredible. Biochar technology is there, it's ready, but we're missing on the deployment side. And that's where we need to start focusing our efforts more. And then think about, how do we have command and operational autonomy? Ultimately, all of those succeeded from their organizational model. So we need a very nimble and empowered entity. We need to build strong partnerships. We need to get away from the bureaucracy. And we need to bring a lot more business impact and leadership into this to think how to scale. To get to gigaton, somebody's going to have to make money. You're not going to fund gigaton scale if all we're doing is asking for money from the government. And we need that input and partnership from the very beginning. So I want to thank you all for a great week, great invitation to learn and partner with you all, and look forward to working with everybody in the future.